Hello, and welcome to another one of these ADD videos. Today we're going to be looking at this trigonometric limit. We're going to have to think a little outside the box on this one. So take your time and try to think of an approach without using L'Hopital's rule that you can solve this limit. If you remember, there were some trigonometric identities that we wanted to make the argument of our trig term and the denominator the same. And as long as they approach 0, which 9 minus 9 is 0 and 3 minus 3 is 0, so if I can get these two to match, I can use the trigonometric identity. So the first thing I need to do is factor it out just to compare what I have up top and bottom. And what you should notice when you factor out, this is a difference of two squares, right? So a squared minus b squared, and that's going to give you a plus b times a minus b. And whenever you look at the numerator and denominator, you should notice that the 3 is negative. Here it's positive on top, and here it's negative. Here, they're also opposite signs. So what we got to do is a little algebra. We got to factor out that negative sign. Okay, so we factor it out of both of those to figure out what's left. Take what you had originally and divide by the negative 1, you get negative theta. Negative 3 divided by negative 1 gives you 3. So now we can pull that out in front of the limit sign. Now the goal, since we have the 3 minus theta here and here, we need a 3 plus theta in the denominator. So let's multiply top and bottom by 3 plus theta. Alright, so this 3 plus theta will be going here in the denominator to get our identity that we want, because the argument and the denominator must be the same. And then we're going to write the other 3 plus theta out here in front. Okay, don't forget the negative sign that was out here to begin with. And then here we have the identity, essentially. So at this point, if you want to say this goes to 0, most professors would accept it. If you want to go that extra mile and do the substitution, then that's fine. On the first part, we're going to have a negative. Plug in, you get 3 plus 3, 6, which is negative 6. And then on the second part, if you do a substitution, you would let t equal 9 minus theta squared. And as theta is approaching 3, if you plug in a 3 there, you get 9 minus 9 is 0. T will be approaching 0. So if we have 1 minus cosine t, right, because we substituted over t, and t is approaching 0, that whole thing will approach 0. So what we have is a negative 6 times 0, which gives us, oops, I forgot the negative there, didn't I? We have a negative 6 times 0, which gives us 0. Alright, so the goal, again, was to make the denominator the same as the trig argument. So we did a little algebra, factored it out to see what we needed to do. We factor out the negative sign to make the 3 minus theta the same. Then we realized we need a 3 plus theta, multiplied it on top and bottom, and then wrote it in a manner in which we could clearly see the identity. Here we have the 1 minus cosine, the box or asterisk over the box, as long as the boxes are the same and the boxes are approaching 0. Right? Even though this says 3, when I plug it into here, 9 minus 9 is 0. Same thing on the bottom. It's a little bit easier to notice identity if you do the substitution. Then you plug and chug and you get 0. Alright, I hope this clarifies trigonometric identities a little bit more for you, enough for you to practice. Again, that's the key to all these problems is practice, practice, practice. Thanks for watching. Have a great day.